Welcome to the second tutorial of Simware. In this tutorial, we are going to see the whole process of Simware from the data model to the use of data. Here we can see the whole process. We will start with a data model. This data model can be based optionally in a phone data model. And then we will use the tool called Modeler to create the same representation of this data model into our libraries. The output of Modeler will be the representation of this data model put inside our multi-core library called Simware Sim. And this will be the base of the whole simulation. Additionally, we will see that Modeler can have two other outputs. One of these is an XML file that will be used for Sim developer for making the simulation models. And the other is an XML file for GPU to create what is called the panels. We will talk about the panels and the meaning of this thing later. Then we will see how in the runtime, by using the scheduler and a configuration file and ACS, we can manage the whole simulation. For this tutorial, we are going to use the example called Simshapes. Simshapes is included in the installation of Simware. You have all the documentation, all the source code, and all the applications that can run of Simshapes on it. Everything I will show you here is in Simshapes and in the installation of Simware. Well, Simshapes is a simple example that has all the possibilities that we can make with Simware. In Simshapes, we have three simulation models. One is a square with a behavior, a movement in this case. The other is a triangle that moves, and the other is a circle that moves. Well, in Simshapes example, we also have a scheduler and one sim engine in this case, and ACS. On the other hand, we also have a client for viewing the squares, circles, and triangles moving. This client has been made by hand and is an example of code made by hand. Additionally, and this will be out of this tutorial, we have gateways that can be used for connecting with Mac or Pitch. So let's start with the modeler and the data model. In this tutorial, we are going to see the automatic process of creation. The user don't need to see any C++ code or to compile any C++ code. The tools, no matter if we are in Windows or Linux, will be able to compile the libraries. This can be done because we are using CMake and we are detecting, using CMake also, the compiler that is available in your machine. So the first thing is we start with the modeler tool. So in this case, we go to the command line, we open the installation of Simware, and the first thing always is registering the bat file of Simware. This bat file has all the dependencies that we need for compiling, all the dependencies, all the paths that we need for finding the right place for all the code, and also for the runtime, for having all the elements that we need for running everything. So by registering this bat file, we can guarantee that you can do anything with Simware and compile anything with Simware. So now we are going to launch Modeler. So we go to Simware Core being in this case, and we launch Modeler tool. We just open Modeler, and we are going to open the data model of this example. This data model is included in the Simware installation. Well, here we can see the data model. This data model follows HLA phone model structure. It has objects with HLA object root, which is mandatory in HLA. It has interactions with HLA interaction root, transportation, data types with all the possibilities of data typing, and one thing here that is not in the HLA standard that is called simulation entities. Well, what is simulation entities for? Well, simulation entities comply with HLA DTD, in this case HLA 1516 2000 DTD, and it's an add-on we have put into the file for us to know which are the models we are dealing with in the simulation. The idea of simulation entities is that here you have the description, the naming of all the simulation modules that you will have and all the simulation services that you will have in the simulation. The difference between simulation service and simulation module is that the simulation service is a module that provides information to one or more module. For example, if we have a service of altitude, it can provide information to planes and also to helicopters. We also have here, important to know, the initial conditions object of the simulation entities. Why? Because at the beginning, the entities, the helicopters, the planes, the actors of the simulation can have different parameters for initial conditions. Maybe they are maybe the same as during the runtime, or maybe they are different. In any case, we separate them. So now we have these entities, and this is the first thing we have to declare, which are the actors of the simulation. And now we are going to go to objects and interaction and declare the objects and interactions of the simulation. For example, here we declare the objects of the simulation. In this case, we have the object shape, because the squares, triangles, and circles are shapes at the end, that has different attributes like size, color, etc. We have the circles that inherit from the shape and has different attributes like X and Y. So how can we integrate that with the entities we declared before? Well, the key point here is that we have to declare which entities publish and subscribe these objects and attributes. So we are making a relation between the entities, the actors of the simulation, and the attributes and the objects that will be at the end the real data in the simulation. So we are saying here that the circle, for example, will publish this attribute of the object called circle. The name could be another, of course. So this is the way we integrate entities and objects. Well, initial conditions, just in case, because sometimes the initial conditions are different, we have a special place for the initial conditions objects, and then we have also to declare the entities of initial conditions in related with these initial condition objects. So now here, for example, we have the initial conditions of the circle, which is an object with all these attributes, and we are saying that the initial condition entity is going to publish the initial condition parameter, and that the object, that the entity circle is going to be subscribed to this initial condition. So that way we are declaring the actors and the objects of them. The same will be with interactions. Okay, so now we are here and we are going to the main output. We are going to put this information, these publishers and subscribers, these things that we are publishing and subscribing, these objects that we are declaring here to publish and subscribe, into this library. Okay, what does it mean? Okay, so we have this library, and what we have indeed is a skeleton. So we have here in the documentation of the product, we have the document of the library. What we are providing at the beginning is just the skeleton of the library. Here, for example, well, this is a document made with the source code of the library. Here we can see the modules of the library. Sim, for example, the main one here is Sim Factory. So here we can see, for example, that we have a function for creating a publisher. But here, this function is referring to generic data. It's just a template and a skeleton. And then what we are going to do now with Modeler is filling up this data with the real object we are using. So now, what we are going to do here is generating the IDL and compiling that into this library, into NCWare Sim library. This will be an automatic process. This automatic process will use an CMake list file and will look for the compiler and compile the library, no matter if you are in Windows or Linux. Of course, in Windows you have to use a specific Visual Studio version, mainly because of the auxiliary libraries we are using, like Boost. And in Linux, you don't have any problem because you are using GCC and there is no problem with versioning. So we generate IDL and compile here. Okay, we need an output directory. We are going to create one here. Output, of course. So here we select the folder and we generate and compile. And let's see what it's doing. Okay. So we can see that it's creating the IDL files and then creating a solution and compiling the solution. The first thing that it's doing is creating this IDL. The IDL is the representation of the data using a standard language. For example, we can see the IDL of any object here. Now this is a standard IDL. We are declaring a module with a struct called square with some attributes of the certain types, and at the end a key list. So now this is compiling the code for you. Well, as I mentioned, this is using CMake, so CMake is detecting Visual Studio version, is finding the right dependencies you set, etc. And all of this is based on the source file we saw. There is no path at all anywhere but in the source file. So by changing the source file, you can move the entire installation of Simware, just like that. Okay, so now here what we have is a DLL and a library that is this thing, is NCWare Sim with the data model incorporated. And we can use that for creating publishers and subscribers. Well, here we have two options. We can create things by hand, and this is covered by another tutorial, or we can use that automatically, as we will see in this tutorial. So this is the base for everything for us. Second stage. Okay, now we are going to obtain these XML files for SimDeveloper and GPG. Let's see what is that. We go back to Modeler, and we go to generate Simware interface definition files, which is the name of these XML files. So we generate them. For example, here we create a new folder to see them. So XML, well, the name is not important. And voila, we have it. And let's see what we have. What we have here is these files. These files are the entities that we declare in Modeler. And here what we have is the use of these entities for publishing and subscribing the objects and interactions of the modeler. For example, if we go to the square and open it, we can see that the square is subscribing to initial conditions object called initial conditions square with these attributes, and that is publishing all these things: data entidad, shapes, color, x, y, etc. So what we have here is the description of the use of the entities in this data model. Now, this is the base information that we need for SimDeveloper and for GPG.